Okay, so we're just gonna finish up the unit. It's over. We're gonna do 2 units together. First is 1F. They call it accounting with order. We know that it's called permutations. That's from the product principle in the first subunit we did. It's not really important, but it's there. So we have to talk about it. The second thing we're gonna talk about is 1G, separation principles. That's kind of cool, actually. Let's just quickly review permutations. Basically, this is, it's counted, we're counting things, but with order. Order matters, and we saw that with the words. So let's just take a larger example. So let's say we have 28 students in a class. And we have to fill 4 posts. Fill 4 posts. Let's say president, vice president, treasurer, and secretary. So we have 4 places to fill, and the order matters. Well, so the question is, how many ways can the post be filled? Now, what you'll notice here is that I did not use the word choose. Choose is only for combinations. There's one question where they use the word choose, but they immediately correct themselves and they go permutations. So that if you do not see choose, you kind of know you've got a permutation. So we know from the product principle, we say, oh, you know what, I'm going 4 slots. And so it's 28 times 27 times 26 times 25. We also know from that first unit, because order does matter, it's a permutation. We know it's 28p4. And we know from the formula that it's 28 factorial over 28 minus 4 factorial, which this is 24 factorial. The 24 factorial cancels out the 24 factorial in the numerator, and we get this product. It all comes together. Once again, if you do not see the word choose, say to yourself, you know what, I have a permutation here. That's basically it. Just do all the problems for 1F. It goes very quickly. Number 11 is the question that uses the word choose, but doesn't. It's all permutation. It's very straightforward. 28p4. Okay. Here's 1J. I want you to think about this. I'd like you to use, so here's 1J. Using the letters from square how many words can you make, right, where Q and U have to be next to each other? Once again, so this is 1G. Using the letters from S, Q, U, A, R, E, I want to know how many words you can make. So immediately you know it's a permutations question, product principle. How many words can you make where Q and U must be next to each other? Pause the video and think about it. Okay, we're back. Any suggestions? Good. So the idea, if Q and U have to be next to each other, we're going to treat Q and U as one letter. So treat Q, U as one letter. Oh, sorry. So that means, sorry, there's no reason for me to rush it. L-E-T-T-E-R. So I'm going to technically think I have 5 letters. 1, 2, 3, 4, 5. So for example, I'll use like E, Q, U, A, S, R. So this is one word. So the idea might be 5 times 4 times 3 times 2 times 1, right? Almost. So you'd say it's 5 factorial times 2. Where does the 2 come from? Yes, because it can be QU, but it can also be UQ. That's where that comes from. So the answer is 5 factorial times 2. What's 5 factorial? 120 times 2. There's 240 words that I can use the letter square, but where QU must be next to each other. How many 6-letter words can I make? Oh, you know what? On the side, 6 factorial is 720. So yeah, it's not that many. Okay, now this one, the letters got kept together. In the next example, we're gonna have to separate them. So, I want you to think of this problem. You ready? Okay. There are, let's see, there are 9 people, right? And there are 5 seniors, right? And 4 juniors. And the seniors cannot sit next to each other. Right? So we have, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're going to be sitting in a row. The 5 seniors, the 4 juniors, but the seniors cannot sit next to each other. They just can't because they don't get along. How many ways can we arrange this? How many ways can we arrange the students? Pause the video for a second. Think about this. How are we going to arrange them? 5 seniors, let's call them S. 4 juniors, we'll call them J. I have to put them here, but once again, they can't sit next to each other. Pause. Okay, welcome back. Well, any suggestions? Well, you know what? I'm gonna put them, the seniors, apart. 1, 2, 3, 4, 5. So that's where the seniors sit. Where do the juniors sit? Well, someone might say, well, can I put one here, and here, and here, and here? And the answer is no, because these 2 seniors will be next to each other. So that means the juniors have to, a junior has to go there. This is how it looks. So what's the next step? Well, once you've got the visual, you can see, okay, you know what, my seniors can be arranged 5 factorial ways. And my juniors can be arranged 4 factorial ways. Answer, 5 factorial times 4 factorial. And what's that? You need a calculator. Or you can leave that. I view it would be fun if you left it like that. Right? Okay. One last problem though, something to think about. These are just fun little things. The last question is, this got me. The last question is, let's go back to the word square. Back to the word square. I want you to come up with how many 6-letter words can be arranged so that none of the vowels are next to each other. How many words can be arranged so no vowels are next to each other. What do you think about that? Put the video on pause. Think about it. Maybe even like call a friend up. You know, when you're watching, you'd be like, did you watch the video yet? Like, did you get Mr. Alex's last question? Right? Okay, pause. Okay, welcome back. So, well, I know that I have 6 letters, right? So I know it's gonna be 1, 2, 3, 4, 5, right? And what do I know? Oh, 5, 6. The vowels can't be next to each other, right? So I have, well, you know what? I'm not gonna do spaces, sorry about that. I know I have vowel, 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 right? Everyone's clear on vowels and consonants. If not, look up these words. Vowel, consonants. Once again, if you're not sure, look up those words, please. And then, so we have vowel, vowel, vowel. So first of all, how many ways can the vowels be arranged? Well, the vowels can be arranged 3 factorial. Okay? What definitely has to go there? I definitely know a consonant goes here, and a consonant goes here, right? Right? But I have 3 consonants. I have the S, I have the Q, and I have the R. Whoops, there. So, for example, I can put consonant 3 here, right? And so how many ways can I arrange the consonants? So you'd say, okay, 3 factorial also, but you know what? Is this the only way I can put C3? Where else can I put C3? You can say, oh, you know what? You could do it C3 here, or you can put C3 right here, right? So I have 2 consonants here. I could put it right here. So I have my 2 consonants here, or I could put it over here, which means it's 4 ways. Final answer? Final answer? 4 times 3 factorial times 3 factorial. Final answer? 36 times 4, 144. These are fun things. Work on 1G, work on 1F and 1G, and we're done with chapter 1.